right, Hugh, if you want to begin, feel free to unmute your mic and we can get started.
Hi everyone, thanks for joining the webinar today, myself and Dr. Wolf. We encourage you to use the chat feature in the program. It'll be monitored and we will try to address all questions at the end of the presentation. If there are any questions that do not get answered because of time, we will post and email them to everyone after the meeting. So introductions first. My name is Hugh Jones. I'm the Europe Sales Manager for VES-Artex. I have been with the company just over 2 years, and I help customers design ventilation concepts and systems to optimize animal health and productivity on their dairies. Dr. Wolf is an extremely knowledgeable in his area of expertise and is very passionate about what he does. He graduated from the University of Minnesota and is the owner of Country Doctors Veterinary Service in Menominee, Wisconsin, in the United States. In 2007, Dr. Wolf started working with VES as a consulting veterinarian. This role has involved research in barn design, fresh airflow delivery, and cooling strategies in new and refurbished adult and young stock facilities. So over to Dr. Wolf.
Thanks, Hugh. Appreciate you all joining us. To you, it's evening where you are, and I appreciate you taking time out of your evening to go through this, and hopefully there's some value that can be brought and inspire some questions and thoughts on your part as to how some of this can be implemented on either your dairies that you work with or our ownership of. So anyway, we're going to look more at retrofitting, but we'll talk a little bit about some new, but the concepts remain the same regardless. So this is a shot of my clinic. I have 3 associates that work with me, and we do the range of practice. But again, as Hugh has stated, I've pretty much been dairy practice for all my 42 years, and I'll just leave it at that. With Hugh did a fine job of just describing kind of my role as evolved here with VES, legacy VES, and now the merger of VES and Artex. So with that, we'll continue. So again, our whole goal here is from the time that calf is born until that animal becomes a mature animal and is done its productive life for the herd, we want that animal to be as healthy and as best well-being as possible as it's gone through that entire life cycle. And we have a huge investment in dairy because we're looking at several years of investment between the growth phase, entering the herd phase, getting payback for that first 2 years, and then becoming a productive animal for hopefully a few to several years after that, hopefully. So in order to maintain that, we have to take care of that animal's environment. So I was looking at the ventilation strategy. It's got 3 legs to it that have to be in balance. So number one, we got to have some way of creating air exchange in the barn. And whether we are relying on Mother Nature to do that, and she can be a bit fickle as to what direction she's blowing from and how long and how hard she's blowing and how that relates to other buildings and structures can have an impact. And that's why more of the popularity of doing some sort of power-assisted ventilation in facilities has become more of a popular as our animals become higher production levels, and removal of heat becomes more necessary as well in cooler to cold climates of managing that period of the year too, and when things are slower, but we still want to maintain air quality. So next, we've got to come up with an effective cooling strategy, and part of that, the big part, is moving air over these animals to remove that heat from the environment and off their bodies. And part of the way we make that even more effective is that we use water by soaking these cows either at the feed lanes or in the collecting yards and holding pens before they enter the parlor. And along with that, we're adding the air velocity over them to evaporate that water. So that's what I consider my balanced strategy. It has a air exchange, get the oxygen in, get the bad stuff out of the building, and create the airspeed we need for the season of the year, and make sure we're supplementing the cooling effect. A cow sweats about the same as what an adult human does. So when you think of an animal that's significantly larger and has a lot of heat that needs to be dispersed, they're not as efficient as removing heat from their body by sweating. And so that's why we use direct soaking, and in proper climates using high pressure fog. So this is giving you an idea of just how much a human is like a 100-watt light bulb, and a cow is going to be like 16 of these. So there's a whole lot more heat being produced by the feed that animal is ingesting. So you got the heat of fermentation in that rumen, and subsequent metabolism as that whole feed chain goes through the body. The muscle movement and all this creates heat that has to be dispersed from that animal's body. And anytime we have excessive environmental conditions, that's going to challenge how well she can disperse that heat. These are some cows under extreme heat stress, and hopefully we don't want to see this very often. And in many of the maybe northern European and UK climates, this probably doesn't happen a lot, but there's effects of heat stress even before we see cows at this level. And if you see cows, even if moderate heat stress, if you have cows that are owning the water, and generally those are boss cows, that the subordinate cows are not going to get their chance at that, because those cows want to make sure they can drink when they want. And it makes cows stand more than what we'd really like to see them. And again, they're hogging the trough, so to speak, and they're not getting the full advantage of their access. Another thing we'll see with cows under heat stress is they won't lay down as much as they should. If they do lie down, they're shorter bouts, because when the body heats up and they get much over 39 degrees Celsius, they want to stand up and get airflow around them. So that encourages cows to stand, and that puts more pressure on the feet. If we see perching in the stalls, that can be an indication of stall design that's causing that cow to do that. Or it can be that cow is just plain hot and she wants air moving around her. But she's going to put more stress on her heels here, because she's elevated in the front, putting more pressure to the back, and that can result in more lameness issues. And also the standing time puts extra stresses on that foot. And for every hour of decreased lying time, we're going to lose about 1.5 kilos of milk production, marginal milk, because that cow wasn't lying down and sending blood to the udder. She's sending it to her muscles to stand. So we want to avoid this type of behavior. So these are recommendations that have been used across many industry recommendations of organizations, that to avoid 1 to 2 degrees Celsius increase in external temp versus the inside of that barn. So we don't want that inside of the barn to be much more than 1 to 2 degrees Celsius higher than the outside of that barn. In many areas, getting some insulation into that roof helps both with condensation in more of the cold and cooler times of the year, and also reduces the convection effect of heat coming in from the roof. Air quality, again, we want that fresh air to be introduced, and whether we want it passively, I call it, and that's relying on Mother Nature to do it, or if we actively introduce air into there by using either a negative pressure or actually push air into the barn and then distribute that with other fans. So again, we want to remove the humidity from that barn. That's another important factor. And so again, that helps with drying the bedding if we can move that air through and down at the animal level. And it also is better for just heat disbursement. And we'll talk about that just a little bit later. And again, there's gases that are coming off from the cows, whether it's coming from silages, from their rumens, and ammonias. There's a number of different gases that are present in that barn, and we want to make sure they move on, because they can have impact on animal health, and both respiratory as well as even foot health from ammonia. And we'll talk about that a bit later here too. And again, we don't want pathogens that can cause disease, but there's also other bacteria, molds, and sort of organisms that are in that environment that could be in the bedding or whatever. And anytime they're present, you're going to tend to increase the the immune system has got to deal with these things when they're brought deeper into the lungs. So we want to make sure we're evacuating those elements out of the barn on an active level. So we're going to talk about two ways that cows lose heat, and one is called sensible heat loss. So that's when you got air moving over the skin, and that doesn't count evaporation of sweat. That's just you got air moving over the skin, and it's moving heat away from the body. And then we have the cooler air that the animal is bringing into its respiratory system is also a way of exchanging heat back out through that by heating that air, and that's expelled. When the animal drinks water, it comes into the rumen. It helps kind of cool down the heat that's going on in that rumen a bit, but it also has that cooling effect from the blood flow through the rumen to help with the animal maintain its homeostasis or its steady core body temp below that 39 degrees Celsius. And in some environments, we'll use a high pressure fog with high airflow to kind of cool that air that's around the animal. And it would also cool the air that the animal's inspiring also to help cooler. And then you have conducting cooling just in contact with the ground, whether it's sand, whatever bedding material might be there. There's been efforts tried with water circulating through water beds and whatnot to help pull heat out of the body to help keep that cow down in that space for a longer period of time. And then we have what's called latent heat loss. That's the evaporation. That's where water comes in terms of, again, we talked about the sweat earlier, that a cow is not a very efficient sweater, say, compared to the horse. And so it's hard for her to disperse that way. So we're kind of producing artificial sweat for her by soaking her with water when she's at the feed alley or when she's in the holding pen collecting yard to cool her, as well as supplying enough airspeed over that animal to evaporate that water and cooler. And generally that's stopped before they, again, enter the parlor, let's say 6-8 minutes before we stop that, keep the airflow on them so we dry that animal so that we're not increasing our mastitis risk. So again, and then we also have the humidity that's coming out of the exhaled through the respiratory system. So again, this is looking at some studies that were done. If we increase the airspeed, the temperature that the cow starts getting in distress goes up. So that's an advantage to have more airspeed over the cows. If we increase the humidity, that has a counter effect on where that animal is going to become into heat stress. So there's that balance between air speeds and humidity control. And again, the effect of the airspeed on that threshold when we start having a higher humidity level becomes a play, especially in very humid climates that we see, like in Southeast Asia or even some Middle East climates where, surprisingly enough, they have some really intense humidity times. So they're going at higher levels with airspeed. This was a study done with Dr. Modenka. He's actually on the VES-Artex team now, and this is a study he did just looking at where's our optimal airspeed, and it seems to be somewhere between 2 to 400, 1 to 2 meters per second. It seems to be where you get the most bang for your buck out of this, how the hair will transfer that heat. But again, in higher humidity climates, there's still a bit more to be gained, and that many times is taken advantage of or helped by putting fans closer together to maintain that velocity intensity. Here again, we start looking at the sensible and latent heat. If we're right around 21 degrees Celsius, there's pretty much a balance between how that cow is losing heat, both the sensible way, which again is that airflow over the skin, the cold water, fogging ground, and just that sort of effect. The latent heat again is from the water and sweating, so they're quite in balance. If we go up to another 6 degrees Celsius, now it's switched pretty much completely over here to the latent heat, which again, we have to cool those cows by putting water on it and evaporating that. So you can see where that switchover comes here. And this again, when we start talking about temperatures where cows are under heat stress, they're starting in that, depending on their production levels, in the near 20 to 21 here is where they're starting to enter into heat stress. So again, this is just going back to roofing, that there's been studies done that getting insulation under that roof helps with the condensation effects that might be seen in certain climates. And it also, by doing that, you inhibit molds and mildews from growing on those elements, which actually, if they're there long enough, actually decrease the life cycle or the lifetime of that building elements. So this is looking at ammonia, cows versus calves. We got the target is to be less than 5 parts per million on the calves. If we go over 5, we're starting to see reduced feed efficiency. Greater than 10, you're starting to have effects on average daily gain, and over 20 is an increase in respiratory disease. So we definitely want to make sure that we're ventilating calf barns enough to keep those ammonia levels less than 5 parts per million. On the adult side, a little more forgiving on the cows. We can be try to stay less than 20 parts per million. And these, again, the different levels. If we're getting over 50, they're starting to get throat and nose irritation, and you increase the risk of respiratory disease. And again, the workers that are in these environments, they're going to have an exposure to that also. Here's a little note that's not often seen, is that when we have higher ammonia levels, especially over like slatted floors that are getting more full, and we don't have ventilation, we'll see an increase in digital dermatitis in those animals because of the effects on the skin at that hoof level and heel. This is a study that was done looking at air speeds, that they took cows, warmed them up to 40 degrees Celsius and see how long it took for them to cool. And if you bring the air from the front to back, is what the FRT is. This is how fast that will go. And you almost need to match what you get from the side to get the same cooling rate. You almost need another 50% more airspeed on that to create the same cooling range that you can from having that air at the side of the cow. So that's getting into how we're putting air at cows that's more advantageous, and it takes higher velocities if it's flowing like in a cross vent situation versus a tunnel barn or a natural vent head-to-head stall situation. So this we're counting on with Mother Nature. If the wind blows over the building, we're relying on thermal buoyancy here to, when there's not that much airflow, we're relying on thermal buoyancy to rise up and go out. So if you don't have the right animal type in here, and you have this kind of high walls, kind of turns into a bathtub, then this air is not going to rise. And that's what happens with smaller animals and calves, that there's not a lot of thermal buoyancy to drive that natural ventilation when there's no airflow. If we have it more open, again, we're getting the air coming through, we're getting more turbulence here, and it'll flow through. But again, we don't know how long is Mother Nature going to blow and for how hard, and what direction she's going to be hitting this building. And then we go to this scenario where the barn is closed up here in a winter mode, and we're getting some circulation here, but we're not getting a lot of exhaust out of the building. So again, the combination of thermal buoyancy and just how Mother Nature is hitting that barn has a huge impact on how it's going to ventilate. So these are all some different types of fans that are in the industry, and this is not meant to be inclusive. We got the smaller, let's say 36-inch, 1 meter type fan. We have like maybe 1.5 meters here, industrial ceiling fans. We have this type of they're panel fans, or in round shapes like this. There's several different like this on the market. And then we have the louvered type fan here that's real high volume, lots of coverage, and we'll get into the application on these. So again, these are some fan mounting recommendations as to how we set these fans up. So if you take a traditional panel or that basket fan, we want them to be tipped 18 to 20 degrees. So we're actually pushing that air down to the animal level and not just pushing air up where the birds are. And again, we want to mount these fans so they're at a safe height for a human and equipment, so they don't get damaged either by cows or equipment in those facilities. And again, we're targeting that 2 meters per second is where we'd like to see that for our summertime ventilation through that living space. And again, the spacing is now the new recommendations here of looking at how far should these fans be apart to get that coverage that'll give us that higher airflow speed that we want. and especially in the beds, and if we can get it also at the feed area. The other thing we have to look at is how wide does that pattern go, and then there's a lot of application with the large ceiling, the high volume, low velocity HVLS type fans are sometimes incorporated in the barns, and we'll talk about that in a bit also. So again, when we start looking at how much fan do we need, the smaller fans, we're going to need more of them to create the environment that we want. And so both the wiring costs, to control all these fans, that's where the industry is going more toward larger fans that cover more area, both laterally and lengthwise in the facility, to create the environment that we're desiring to get done. Now, sometimes due to structural obstacles, height of roofs and things like that, brings that down to a smaller fan. But the idea is we need to get as wide a coverage as we can at the cow level to achieve that optimal environment for the cows. So we'll start out here just quick with calves. Here's a simple design that somebody, it's got polycarbonate on the side for sunlight to come in. This is closed. There's like a rubber belting or something here to block this. And this barn is run as a tunnel barn. There's exhaust fans here for these calves. Here's another one that was done. This one has ceiling fans in here. So this barn is exhausting air through, pulling it in through an inlet, and the ceiling fans are mixing that air as it moves down through the barn. Same here, we have pressurizing fans pushing fresh air in, and the ceiling fans can be run at the different speeds in order to accommodate the comfort area for these calves. So we're not chilling them in the cool times, but in the summer, both for helping with flies, because flies don't like air speeds like over 1.5 meters per second. They tend to not stick around. And we also cool the calves, and also this will dry that bedding and make it last longer by moving some air through that building. So this is a way of ventilating a calf area. Here's another one. There's a fellow I know in the UK here that just did this install on a barn that he was having trouble with respiratory disease in here. You can see he's got spaceboarding on the side. There's openings here. The ridge is marginal here as far as outlet here, but you can see that these calves are kind of like in a bathtub here, that getting the ventilation down to where they live can be difficult. So in this strategy, there's fans blowing air into this barn, appropriate for the speed that we want. Again, it's above the calves, so we're not drafting them directly, but the ceiling fans are moving that fresh air down into the calf environment. And this has been a really great success for this individual on just doing this sort of simple retrofit. And those ceiling fans are relatively a very modest priced way to help with destratifying and mixing that air, so you get the fresh air down where you want it and get the ammonia and the bugs and down at the calf level out of there. This is another one that's cross vent design with auto feeders. Same idea. Air is going to be pushed in and then moved around with the ceiling fans, and then exhausted either just by natural through venting, or it can actually be removed by other fans. So fairly simple design, and then can be quite effective. This is a cross vent barn. Just visited this one. It's one that was done about 3 or 4 years ago, and they background the calves here in these up close little individual area for 10 to 14 days, and then they move on to the auto feeders. In the wintertime, the air is brought through the ceiling vents. It's mixed, and these fans are adjusted so they do not create a draft at the calves. So we want that air speed to be, down in the, gotta do my conversion quick here, that about 88. So we got about maybe a quarter to a third of a meter per second at the calf is not a drafting airspeed. And so the air comes in, it moves across and is exhausted by appropriate exhaust fans. As it warms, the curtain opens, and there's, because we're leaving the static, we're not pulling the hot air out of the attic. It's coming across with this through the barn and exiting. So we're not dragging a lot of stale air over a lot of calves if we pulled the air the other direction. And again, they stated their death loss and pneumonia rates are down in the 1% area. They're very pleased with this sort of setup. This is another one in the UK that's just a simple negative pressure barn. Exhaust fans down here that can be run at different stages. He's got polycarbonate on the lights on the side, so we don't have to worry about rain getting driven in here and wetting all this bedding. And this is the inlet where the air is pulled into the building, and then he's got this shed dormer roof over here to collect the rain and take that away, so that's not getting pulled into the barn and wetting the bed on the near end here. So this is a design that's worked well also. Let's go to adult ventilation. Here we have a natural ventilated barn. We got an open ridge row. We got curtain sidewalls. And here, placing these larger fans over the beds is concentrating that where we want those cows to spend most of their time. In a more aggressive situation, if people desire, we can put some smaller fans here over these cows. This barn does have soakers here lined, so combining that with airflow and again makes that a huge cooling opportunity for these cows. Here's a design just based on, we have recirculating fans, and again, many of the barns, in the UK are built one next to the other. So even though the wind is blowing outside rather intensely, doesn't mean the barn is going to ventilate well, because there's all these obstructions to airflow getting into the core of that barn. So the design here is we push some fresh air into that building, and then the larger fans here will help direct that air down through over the cows in the stalls. And then it can exit the barn either through the space boarding or the open end on the other end of the barn. We generally try to make this so the prevailing winds are working with this design, so we're not trying to fight Mother Nature in generally any of these designs. Here's another example here. This one actually had use the large ceiling fan concept, and they've since converted over to the louvered fan, because this is putting more airspeed where we want over the cows. And I'll show you in a second some research that was done on this type of fan. This is a great fan for mixing air and then destratifying, just like the smaller ceiling fans we use in calf barn applications. But in this application here, that air comes down, hits the floor, and does not reach where the cows are lying very well. They're more expensive per unit, but they're very efficient in terms of their operating costs. So that's one plus and why that does appeal to some people. But this is what happens here. This is 20 feet out, so what you're talking 6 to 7 meters from where that fan is, and the cows are lying out here in this area in the cubicles or the freestall beds. And this area here is below that 200 feet per minute or 1 meter per second area that we want those cows to experience. Some people will use smaller fans, but then you're limited by where you can space them because of posts in here. But again, that could be done over this area, but it takes many more of those fans, smaller. And again, they're primarily a recirculating fan, and we have many people relate that they'll actually have drier bedding when we have fans actually pushing air through the building in an intense pattern versus just mixing it. So that's another plus for the more directional flow type fan setup, regardless of the size. This is more of a just an example of a powered tunnel ventilated barn in a dry climate that's very intense on the flow over the cows. It's a 6-row barn. They eat on the outside, but this is some of the examples of what some parts of the world and dairy industry are doing with ventilating cows in a very hot and dry climate. So, and there's other examples of that, but it doesn't necessarily apply, but I just wanted to show you parts of what's going on in other parts of the world here in terms of ventilation approach. I'm going to call this a ventilation application tweak. I mean, they've done a great job here putting lots of fans here on both examples here. But the problem is they're not really well directed to where the cows are. Here, this air is going to come in high, and we want that air to be coming down at the cow level to bring the air that's going to come in this sidewall from the natural ventilation to grab that and direct it here. So if it's coming in high here, we're not really getting that airspeed. And you can see in this barn also, Again, great number of fans down the sidewall, but where they're directed is way over. And so these cows here would get very little benefit from that fan the way they're mounted currently. Here's another application, really good intense fan spacing, intensity in a collecting yard. But again, the fans are more straight on, and we need to have that airflow going down at the cows. Same way here in the same application in the freestall. They got a good amount of fans that they're covering this area, but they're primarily just blowing from one fan to the next. And that may help with some heat removal, but we're not getting this air down here on the cow. They do have soakers here. So combining that with a little more airspeed here would definitely be advantageous. And you generally recommend this to be a little lower so that we don't have so much turbulence blowing this water out onto the feed and wetting the feed. So those are things to take into consideration. So in this application, just changing how those fans are directed, perhaps spaced, maybe fewer fans could have been used in that application. But again, I like the intensity that they're trying to do here. But again, it's how it's applied here that has an impact on the cow. Again, louvered fans can be misapplied too. This fan is way too flat. These louvers are way too sharp. This fan will never perform, for the investment that you made in it to actually create that airspeed and coverage because it's just choked too much here with the way these louvers are. This is not what I call a plug and play fan. You need some good advice from your installer on how to mount this fan correctly and direct these louvers. Then there's some standards that come with this equipment to help you get that initially set up. The other one, you can see some here in this one, and this one that's a little hard, but these fans are too close to the ceiling. That fan is going to start moving air into that throat about 9 feet out in all areas around us. So anything that restricts that is going to restrict how much air comes out the outtake on this fan. So it's hugely important to be noticing what's restricting that. And again, there's mounting instructions as to what that should be placed at to get the optimal performance out of that fan. Here's a beef barn application. This is in the UK, beef barn, that again, pressurizing fans that run at different temperature levels, the smaller one during cooler times, and then the addition of the larger one when it's warmer. And now again, that air is being moved through this building by these louvered fans, large fans that are helping bring the fresh air in and then move it down through the building. And this helps with animal health as well. The owner has noticed that the bedding just lasts longer because we are moving fresh air through this building. This one's a beef application here in the States using that same fan design. These pens are around 18 by about, I think, 12 meters wide over a slatted floor. Had lots of respiratory disease in these inner pens. The outer ones worked fine because of the natural ventilation from the open ridge row, but in these center pens, he would tend to have respiratory disease and foot issues. And by moving this air over this slatted floor, we're removing the gases that want to come up out of this and moving out through the building, as well as the floor is drier, so the animals have better footing. And again, we reduce that possibility of digital dermatitis because we've got a drier area for that foot of where it lives down here close to those gases where the ammonia is. Let's talk a little bit about parling and holding pens. It's always a place that a relatively small investment covers a lot of your cows because every milking cow that you have on the dairy is going to come through here at least twice, if not 3 times a day. So we want to use that opportunity to make sure that we're creating a proper air exchange of 1 minute air exchange. And again, we have a very high stocking density there because of these cows being packed together. We generally have a more intense application of how close fans are together and how far apart, both laterally and lengthwise. And again, we're back up here looking at that 2 meter per second. And in some application, we'll use fans to pressure and push air into this building to actually increase its ability to bring fresh air in and move over those cows. And again, including that soaker system, make sure they're covered well. And as I spoke earlier, 8 to 10 minutes before, we want to get them into an area that there's no water so we can dry them before that animal enters the prep area for the parlor. And then we want this to be set on automation so that the system will tell when these things should activate rather than relying on employees to decide when those cows are too hot, because in most cases, people don't realize how fast these cows heat up in that environment, and they'll think it's quite fine, and it's not necessarily the case to a cow that's actually in that tight environment in a collecting yard. This is some data that was done here looking at if we have a 54 kilogram cow versus an 18, as far as how much BTU per hour that animal's putting out, it's virtually double in terms of that cow that's a high producer compared to that cow that's close to drying off and or is going to be dried off. And if we, whoops, I guess my little thing, you're just not coming up on this. So if we look in this area here, our BTU per hour per square foot, when we're out in the barn area, that cow has got lots of area to disperse heat. And so it's more forgiving there. And if we look at the per square foot of the holding pen, that's gone up many times here, 7, 8 times here of how much more foot heat is being produced per square foot. And then we look at skin square foot of the cow versus out in the pen versus those cows packed together. There's a huge amount of there's less skin area to disperse the heat they're producing. So cooling those cows in that holding pen is a very cost effective, and you may find that you don't think your cows as heat stress as that first cows we were showing with their tongues hanging out, but just a 1 Celsius increase in core body temp, you could be losing pregnancies in this holding pen just for that time that those cows are in there with that excess heat on them. So it's been found that guys that include soaking and airspeed over these cows in these holding pens, collecting yards, actually improves their reproductive performance. The screen is froze up for some reason. I'm kind of in a pickle here.
Doc, maybe if you stop share and then
And bring it back up.
Share again, then start from where you ended.
No, that bugger don't want to advance. Guess we have technical difficulties, guys.
Hugh, do you by chance have a copy of this presentation that you could share on your end?
I tell you
Yes,
what here. I'm down to, I guess we're just in the dry cow cooling.
I can share, Doc.
Okay. Sorry, folks, for that. For some reason, the computer decided it wanted to freeze up on me.
So, Dr. Wolf, you'll have to stop sharing then, and then I believe you will be able to take over.
There we go. There we go. Thanks, Hugh. So here's an example where putting some air speed over these cows in the parlor is important. So just using smaller fans here is quite effective to put air over the cows. And what I'm highlighting there with the arrow is pointing that those fans in there are pointing down to cool the people that are actually working in the parlor. And on the right, again, we have fans that are over the cows, as well as these larger fans that are pushing air down through the exit alley from the parlor area. You can go to the next slide, Hugh. This is a rotary parlor. So again, we're pressurizing the barn with the 4 larger fans to push fresh air in. And in certain applications, we'll actually put high pressure fog on there to kind of help air condition that barn. And then as we look to the right, we have fans over the cows while they're on the deck while it's rotating to, again, bring fresh air in. We're producing food in this area, so we want this to be kept cool and clean for both the employees and the cows. And we're pushing the hair, dirt, grease, and stuff that comes off of cows out through the holding pen. We don't like to be bringing air from the holding pen into the parlor area because, again, that's where we're producing food, and the elements that come off cows themselves can just make things more dirty in the parlor area because of that. So we like the air coming in fresh and then exhaust it out into the holding pen. You can move again then, Hugh, please. Again, this is a setup in a holding pen using different fan styles. Again, you can see the intensity. We want that angle pushing down at the cows. These pens generally have soakers in them. In this case here, they've actually got a wash pen for washing the udder, which is typical in dry lot dairies here in the States. And on the right, again, we have the louvered fan creating this massive airflow down through that holding pen, collecting yard. It's going to actually infer air exchange through that building because of the intensity of the airflow. Again, you can move, Hugh, please. So again, let's not forget the dry cows. They're often the most overlooked group on the dairy. There's huge impacts on the animal's transition health as she comes into her next lactation if we cool her. And she will results in better milk production, but there's a lot of University of Florida have done studies looking at heat stress and the effects of programming that calf even before it is born. We tend to see the shorter gestation, lighter birth weights. Again, they don't absorb the colostrum as well. They don't grow as well. They're not going to get bred as soon as they normally would. So you got longer days on feed before they enter the dairy. And there's just overall less milk production when they're entering the herd first lactation. So don't forget dry cows. Again, just like the parlor, it's a great place to invest in cooling that is going to impact every cow that's going to milk on your dairy. So it's a good use of capital to make sure they're covered. You can move again, please, Hugh. So again, in summary, the dairy facilities, it's evolving from what we've done in the past, from just natural ventilation to look at natural with recirculation assist, along with, soakers and other means. We have tunnel barns, cross vent, which we didn't really get into in any of these designs today because that's more of a whole separate topic. We have a lot of robot barns and trying to make sure we get airflow around where we talk about what it is over the stalls area or the bedded area, getting some airflow around these robots to make it appealing for those cows to want to come there and go through the machine. So that's not a isolated kind of a dead spot for airflow and air quality. And again, barn ventilation does not equal cow ventilation because if we're not focusing what we're doing with that air and not getting to the cow, she's not getting the benefit of that investment. So again, we got to look at the air exchange and the air speeds. We want to be looking at below 6 feet of height, and we want to use the cooling strategies that's appropriate where these dairies are. And we want to be good stewards of our resources, so we're not wasting water or electricity. And again, some of the current thinking, traditional thinking is being changed about what do we really need for airspeed over cows, where the current THI index does not look at airspeed. So that's interesting stuff that's going to be coming on that particular topic. Again, you can go there, Hugh. Thanks. So again, the whole industry, we have to be looking at ways we can apply these things better to the animal. We got to look at the cow's needs as well as the cost of doing this and the return on that to achieve that optimal animal-centered environment. And we also want the public to know and understand how concerned we are and how we take care of the animal welfare in these facilities, and even in the climates that aren't as cold in the winter, a lot of times, you're not out on grazing. They're still confined, and we still need to create a decent environment for those animals during those months when they are confined inside the barn. So, and again, if you're thinking about doing any of this, to make sure you work with people that are qualified and knowledgeable how to put these things together that'll meet the needs for your dairy. So, I think with that, I think I'm done. So we can do the questions, I guess, at the end here. And Hugh, I guess I'll turn it over to you.
Thanks, Doc. I will just share my screen. So I'll just be touching on a little bit about the louvered fan, our Ecv fan. Dr. Wolf had mentioned throughout his presentation. So I'll begin. So, as Dr. Wolf mentioned at the end of his presentation, VES-Artex has now invented a new category of dairy system or dairy ventilation, and this is known as animal-centered environments. So we want to make sure that all the energy, all the power that we put into our fans, we want to make sure that it is being put to where it's best used, and that's where the cow is. So we need to ensure that everything we're doing in the cow's environment is centered around her. So when designing a system, wherever it is, it could be in the coldest climate, it could be the warmest climate. We try to look at 5 major factors which could affect the ventilation system. So firstly, we look at the facility layout, and this comes quite often into play in European farms. Is that because farms tend to be quite close together, buildings tend to be quite close together in European farms, that they affect each other's ventilation, which is known as wind shadows. So one building could be a shadow of another building, and this could eventually affect your natural ventilation, and then subsequently affect your cow cooling if you're relying on natural ventilation. We look at the climate and local weather data to see what severity of heat stress you're seeing, and what weather you're actually seeing in the winter as well, because the investment in VES ventilation in general is that it should be used 365 days of the year. We then look at cow data, if obviously we are able to see what is the severity of heat stress on the farm, whether it be conception rates, preg rates, milk loss, milk component drop, fly treatments, whatever it is on the farm that's made you consider the investment in ventilation. We'd like to look at and to see what we can do to make a difference. Obviously, then the geography of the climate, this comes sort of into the weather, but as well as any large water sources which could increase humidity in the farm or anything like that. And the last thing is probably the aims and expectations of you, the farmer, ensure that the ventilation that we're designing will cope with your severity of heat stress and will meet your expectations. So this is typically what I bring up when I'm looking at a system or looking at a farm. So on the left, you'll see the temperature ranges on the farm. This is just based off local weather data, local weather stations to the farm. So we can see the temperature ranges on the farm and where we are % of the year in those temperature ranges. On the right, we then go into, okay, when the farm is above 65 THI or 65, a score of 65 on the temperature humidity index, where are we on that range? So, for example, in this example, 82% of the time, we are between 65 THI and 72 THI, which is considered a mild heat stress. And then around 18% of the time, we are in moderate. And then finally, we just look at the predominant wind flow to understand, okay, why is this building not working in natural ventilation? What is the orientation of the building? Where does the wind come from most, and what speed does it come at? Obviously, each individual farm will know where its predominant wind will come from, but this will just give us a good idea, even when planning new buildings, to say to you, the farmer, this is what our data shows us on your climate. From this, we can actually then give a estimation on power usage of the fans based on settings, temperature settings, which we can put into your system. So in Dr. Wolf's presentation, you saw the Ecv fan and some of those applications in numerous dairies around the world. So the role of the Ecv fan is to provide that effective cooling velocity at the cow. So the actual transfer of heat from the cow's skin to the air. And without that, without cooling by convection as a starting point, you'll not cool a cow. So it's important to remember that this effective cooling velocity should be always directed at the cow. So the Ecv fan will always aim to put airflow 1.8 meters and under, so that there's no wasted power into air velocity. So in high speed operations, it creates a wave of air to cool the animals under 1.8 meters. From this, in the summer, we can see an increased line time and increases in production, whether that be milk or repro as well. An added benefit of the Ecv fan is that we do see a lot drier beddings in European climates. Most notably, probably green bedding or manure solids. We've seen great success by constantly moving airflow at the bed level in these barns. So this is typically what we expect from an Ecv fan, to always aim above 2 meters a second, typically spaced every 18 meters, depending on obstacles. Our 72-inch fan, this is. So typically spaced every 18 meters, always aiming for that 2.3 meters a second. I think what's most critical is to aim for that as the last cow, because obviously as you get closer to the fan, you're always going to get those air speeds. Versus, I always say to the people I speak to, is that you want to be concerned about the cow lying down 18 meters away, not the ones closest to the fan. So this is a plan that we can do when we're designing a barn to show you the airflow pattern of what we expect in the facility, and the different velocities at different distances. So yeah, this is typically what we expect: a throw of around 18 meters, and then a width of around 9 meters, depending on obstruction. So this is just a short video, just explaining the Ecv airflow pattern. So as you can see, each one of these deflectors, I like to say they act as injection points of air. So they're injecting air at different points within the bed, keeping airflow down below 1.8 meters, and ensuring that that cow is receiving the best air quality she can in the environment she's in. It's important to remember that the cow is breathing in this 30 centimeters between the bed and her nose. That is her microclimate. So this is where we should be exchanging air constantly at a speed relevant to temperature, or temperature and humidity. This is Dr. Wolf on on the side of a stall. I hope health and safety don't see this, but he is going to be smoking at the fan just to give you an idea of the airflow pattern expected. This is in a tail to tail setup in the UK around 6 years ago. So this is typically what we expect off the Ecv fan. It's ejecting air at bed level, and as you can see, that it's typically not getting above 1.8 meters until reaching the next one. So all air is being injected at that level. These are just some Ecv applications in Europe. Quite a lot of retrofits. For example, this is a customer in South Wales. A customer in South Wales, and then a customer in Slovakia. So these fans, they aren't just for new buildings. They can be retrofitted wherever possible, space dependent. Obviously, we've got numerous different sizes of fan. So usually we can find a fan suitable to your application. So that is my segment on the Ecv over. I'd just like to touch on our new barn technology called Dairy Boss. Dairy Boss came about because we wanted to connect all systems in the back of the barn together, whether it be ventilation, lighting, cooling, all VES systems together in one place for the farmer to view, and then compare with other systems on the farm, whether it be milk recording, milk quality, repro data, reproduction data. So we wanted it in one place to give the farmer information at his fingertips of what his environment is on the barn, and give him usable data for easier decision making. We see it as digital transformation is coming to the back of the barn. For the last 100 years, we have seen a great improvement in cow comfort, cow environment. But people still do buy components, hang them in the barn, whether that be lights or fans, and there's no real connection to the animal. So barns are not responsive to animal needs. But barn design has stayed the same whilst the animal has changed. The genomics of the animal have changed. So barns aren't responsive to the dairyman's needs. There's a lot of systems in the barn that don't speak to one another. So the aim of Dairy Boss is actually to bring those systems together and give you, the farmer, one dashboard to view everything. So we are putting a smart animal in a dumb environment currently, or generally, because genetics have accelerated and the animal environment has generally stayed the same. So we need to be putting the animal at the forefront and at the center of our attention, because every unit of energy is spent to optimize the animal's environment, and the result will be better health, productivity, longevity, efficiency, and profitability. Dairy Boss got designed when we considered what were the 5 things that an animal needed to survive in her environment, whether that be water, air, shelter, environment, and feed. And then we sort of said to ourselves, okay, what things determine the animal's comfort in her environment, whether that be ventilation, stalls, manure handling, cow sensors, feed software, herd management software. Those are the things that determine her comfort. And then the last circle is that who are the people that determine those pieces of equipment that go into barns, whether that be herd managers, consultants, nutritionists, owners, VES staff, and veterinarians such as Dr. Wolf. So the whole idea of Dairy Boss was to combine all these things together and make sure that the back of the barn is getting as much attention as the front of the barn. And yeah, we call this Dairy Boss, which stands for Dairy Barn Operating System. So Dairy Boss will go wide across the farm to include as many data sources and operations as possible, and deep into the VES-Artex process to increase efficiency. So Dairy Boss is a combination of motor technology, fluid dynamics, precision engineering, stalls and building design through VES expertise, advising you on what works best for your building. Sensors, whether that be temperature, humidity, THI, light, gases such as ammonia, and static pressure sensors. And then also we're looking to incorporate in the future video technology, PLCs, status and alerts, to really ensure that we're doing the best for these animals, whether that be video technology, which we are really looking to in the future. And then finally, we want this in a place where it's easily accessible to the farmer and remotely or on farm. So we want this to be in a cloud so you can view your barn wherever you are in the world. And we can as well. So the vision of Dairy Boss is to connect all VES solutions in one unified platform, or VES-Artex solutions in one platform, to integrate and control most of the dairy operations plus key data sources, to provide insights for dairy managers and guidance for farm labor, and then obviously to become the industry leader in dairy farm operations. I can give you a quick tour of Dairy Boss. I'm a bit cautious of time. I don't want to take too much of your time up. I know it's getting late in some parts of the world. So I'll just give you a quick tour. So I'll just give you a quick tour. Obviously, if you wanted a more in-depth tour, please contact your local dealer, and I'm sure we can arrange something very soon. So I'm focused now on a barn, so we can see inside temperatures, inside versus outside THIs, inside temperature of the last few days averaged out. And what I'd really like to show you is fan groups. So in here now we can see fan group 1, Ecv fan group 1. We can click on it. We can actually view its current speed, its torque, its requested speed, and its power in. So actually this fan is on 63% power and is using 220 watts of power. If you have multiple sites, we can have a company dashboard to see here are your farms down here. So if you've got multiple sites, we can easily view them, check wherever you are in the world. We can see your upcoming weather. If we click on the weather, we can see your up and coming weather through the days to see if you need to be more aggressive on your ventilation strategy than you are being. This is just a quick tour. Obviously, I'm a bit wary of time. So I'll hand over back to Dr. Wolf to take any questions that you had on his presentation. You there, Doc?
There we go. Is there any questions, or do we have time with that, Sue, or whoever, or email these questions? I don't know what the any thoughts or questions that anybody wants to entertain, or?
Hi, Dr. Wolf. I saw one question come in. Paul from the Netherlands asked, what is the priority on cooling cows? Roof insulation, ventilation by fan, cooling by soaking? Thanks from the Netherlands.
Sure. It's, if the barn is already installed, and again, from the viewpoint of what the Netherlands climate is, and I've been there a few times, you're probably less challenged from that solar gain. You probably get more gain in your climate through the skylights that are in many buildings. I noticed when I've been in the UK and elsewhere that you can get kind of hot spots where that sunlight's coming in, and it'll make stalls where the cows may not want to lie just because of that sun during different types of the day will kind of track over the stalls. So the insulation is probably less of a priority in that climate versus looking at the soaking and the airspeed over the cows is quite important. And if you have your druthers, you can soak at the feed lane, but then make it so that the airspeed is more over the bed. So I know I've had guys that had cows bunching because the cows wanted to stay over the soakers, and we just moved the fans so that the wind speed was at the bed, so they come and lie down. They want to get soaked, they get up and go over and get soaked. So that's a strategy probably that would work well in that climate. And again, it wouldn't have to be as an intense or as long a period given the latitude level of where the Netherlands is in terms of how tense that has to be. And again, the holding pen would be a real top priority of airspeed and soaking.
Thank you, Dr. Wolf. That's the only question that I saw come in.
Sure.
What I can do is after the event, I can get you an email list of the participants. And if you guys want to send out something at that time for further questions, that works.
Well, I certainly want to, thank everybody that did join, and hopefully this brought some value to you folks, and be more than happy to communicate with anybody if they'd like to contact either Hugh or I through the VES-Artex resources. So again, appreciate this opportunity.
Yeah, thank you, everyone.
Thank you.